And now it's time for our last section of section 6.3 for college algebra, solving polynomials using the root method. So what you need to know about this is when you have x to some power, you can take that power of a root. Like if you have x squared, you take the square root. If you have x cubed, to undo it, you would take the cubed root. Now, if n is odd, so if you have x cubed and you, let's say 8, and you, or even -8, and you take the cubed root of that to undo it, you will get -2. There's no way you can get +2 because that was a -8, so that's a -2. If you take the square root of 4, then we get plus or minus 2 because +2 times 2 is 4 and -2 times -2 is also 4. So when it's even, we get this extra little plus or minus in the front. So that's just something to keep in mind. That works for higher order powers as well. If I take the 4th root of 16, 2, 4, 8, 16 is plus or minus 2. And keep in mind that you cannot take an even root of a negative value. It's not going to work here. So if I can't take the square root of -8, that would not work. All right, here we go. Some examples. X cubed equals 125. So in order to solve that, I would cube root each side. And if I take the cubed root of 125, I get 5. There's no plus or minus needed because it's an odd value. Now on this one, before you take the 4th root, the first thing you want to do is get rid of that 5. So first we're going to divide by 5, which is 16, and then we can 4th root it. The answer, the 4th root of 16 is 2. But remember, this was even. So when you take an even root, you're going to get plus or minus. So that one should be plus or minus 2. Over here, we're going to divide by 4. That one's not going to come out quite as nice. 18 divided by 4. I would not go with a decimal route here. I think we'll go ahead and leave it. Reduce it, though. Divide by 2, so 9/2. And then to solve that, we're going to square root both sides. The square root of 9/2. Well, I can separate the square root of 9 over the square root of 2. Oh, and don't forget, it's even, so we're going to have a plus or minus follow us all the way through this. Plus or minus. The square root of 9 is 3. But I don't want to leave a square root on the bottom, so we multiply by the square root of 2 over 2. Square root of 2 over square root of 2. And so my final answer is 3 square root of 2 on the top. And square root of 2 times square root of 2 is the square root of 4, which is normal 2 on the bottom. So there's my final answer for that one. All right, let's look at one more problem in this chapter. Actually, 2 more. Sorry. The future value of $10,000 invested for 4 years at an interest rate R compounded annually is given by this formula. Find the interest rate as a percent for which the future value is 14,641. So they're telling me this is the answer, S, and I want to solve for R. So I'm going to put the 14,641 in the equation for S. Plus R to the 4th. And we're going to solve that. So divide by 10,000 and we get 1.4641. 1 plus R to the 4th. And then you're going to take your handy dandy calculator and 4th root that, which I do not have. So we're going to use the answers down here. Oh no, it turned to page. Just a moment. Here we go. Okay, so then you would take the 4th root of it. The 4th root of it is 1.1. There we go. That's what I needed. 1.1. And because it was even, we would have a plus or minus, but you're never going to have a negative interest rate. So we just stick with the positive one, subtract 1 from that, and you get 0.1. So your interest rate is 10% or 0.1 as a decimal. If you want to, you can also graph those. Since you're allowed to use your graphing calculator in this class, you could graph in y1. I would put this exponential equation, 10 times 1 plus r to the 4th. And then in y2, I would put 14,641. Now you're going to have to change your window really high. So you see that 14,000. And your x, you're going to have to change it really low because this is a rate, and an interest rate is probably less than 10%. So the most you would want to have your scale be would be from 0 to 1 for 100%. But this is your 0.1 is your 10% answer right here where it crosses. And you can find that using second calculate the intersect. One more problem. Here we go. The annual number of arrests for crime per 100,000 juveniles from age 10 to 17 can be modeled by this function. X is the number of years after 1980, so keep that in mind. The number of arrests peaked in 94 and then decreased. Use this model to estimate graphically the year after 1980 in which the number of arrests fell to 234. So basically, I would start with graphing this. Try to get this on a graph. Try to see it. We have 1980 for sure. We know we want to go at least to 1994, but that was its peak. And then we want to know when it fell to 234. So we're definitely going to want to go past 1994. So if 0 is 1980, we want to go, let's see how far, to maybe 25 or 30 out here, probably 30. And in the y direction, you're going to need to change that scale as well so you can see it. Because the y-intercept is 361. They probably went from like 1,000 to negative 1,000. Oh, sorry, 0 to 1,000. So they're telling us this is 1980 and it peaked in 1994. So here's 1994. And then we want to know when it fell to 234. So what they did in the intersection method is in y1, you would put one of these things, probably the equation, because you already may have done that. So this goes in y1, this goes in y2. It really doesn't matter which one's which. And then you want to find the intersection. So second, calculate the intersect. And that is it for this lesson. So get started on your 6.3 homework. We skipped section 6.2, so in case you missed that, there is no 6.2 assignment. And we'll continue on with these next week. Thanks for watching.